So, hi everyone. My part of this group assignment was the gradient boosting model for the bank marketing dataset. So, the aim of this project was to predict whether a customer would subscribe to a term deposit after a bank marketing campaign. This is a supervised learning classification problem because the target variable has two classes, yes or no. So, first I loaded the dataset into a Jupyter notebook using Python and Pandas. Then I check the dataset structure, including number of rows, columns, and the distribution of the target variable. One important thing I found was the dataset is imbalanced because there are many more no values than yes values. So next, I separate the dataset into input features and the target variable. I converted the target values from text into numbers where no becomes 0 and yes become 1, like this. So after that I split the data into training data and testing data. The training data was used to train the model and testing data was used to evaluate the performance. So since the dataset contains both categorical and numerical features, I used pre-processing. I applied one hot encoder for the categorical columns and kept the numerical columns as they were. Then I combined pre-processing and modeling into one pipeline. So the model I used was gradient boosting classifier. I select this model because it is a strong ensemble machine learning algorithm and often performs well for classification problems. So after building the pipeline, I trained the model on the training data and then made prediction on test data. So my model achieved accuracy of 90.55 accuracy. The ROC AUC score was 0.924, and which showed that the model had a strong ability to distinguish between customers who subscribed and those who did not. So for the positive class, which is yes, the precision was 0.65. Yeah, the recall was 0.41 and the F1 score was 0.50. It means the model performed well overall, but it is still missed some actual subscribers. This happened mainly because the dataset is imbalanced. I also included visualizations such as target class distributions, and confusion matrix, ROC curve, and the feature importance graph. So these graphs help explain how the model performed and which features were most important. One important finding was that duration, this was very influential feature. This helped the model make strong predictions, but it also a limitation because in real situation the call duration is known after the call happens. So in conclusion, the gradient boosting model gave strong overall performance. And was one of the best models in our group comparison. It showed that gradient boosting is a very effective algorithm for this dataset and classification problem. Thank you.
Everyone. Now I'll be explaining my tandem forest implementation using the bank marketing dataset. The main problem I have addressed in this notebook is predicting whether a bank customer has subscribed to a term deposit or not. This is a binary classification problem because the target variable only have two possible outputs, which is yes and no. First, I have imported the required libraries. I have used Pandas and NumPy for data handling, Matplotlib for visualization, and scikit-learn for pre-processing, model building, evaluation, and hyperparameter tuning. Next, I have loaded the bank marketing dataset and displayed the first few rows. This is helped to understand the structure of the dataset and check whether it has been loaded correctly. After that, I have checked the dataset size and the distribution of the of the target variables. This is helped to understand how many records and dataset contains and whether the target classes have been balanced. I have also explored the dataset further like this by checking the data types, missing values, and summary statistics for the numerical features. Then I have separated the dataset input features and the target variables. I have stored the input columns in X and I have converted the target variables into binary numeric form in Y, where no has become 0 and yes has become 1. Then I have split the dataset into training and testing sets using 80-20 ratio. I have also used stratified splitting so that the class distribution has remained similar in both sets. After that, I have identified the categorical and numerical features. Since both types have needed different pre-processing steps, I have created separate pre-processing pipelines for both. For numerical features, I have used median imputation, and for categorical features, I have used most frequent imputation. And then I have combined these steps using column transformer. Once the pre-processing is done, I have built a full machine learning pipeline by combining the preprocessor with random forest classifier. I have used the pipeline to train the baseline random forest model on training data. After training the model, I have generated the predictions and probability values for the data test set. Then I have evaluated the baseline model using accuracy, confusion metrics, classification reports, and ROC-UC score. Since the dataset has been imbalanced, I have not depended on accuracy. I have also considered the other evaluation metrics. Then I have improved the model using hyperparameter tuning. I have defined a parameter grid and used grid search CB with cross-validation and F1 score to find the best random forest computation. After that, I have evaluated the improved model again on same test data so that I have been able to compare it fairly with the baseline model. So you can see it here. Finally, I have created several visualizations including the target distribution graphs, confusion matrix, ROC curve, and feature importance chart. These visualizations have helped to understand model performance more clearly and identify which feature have contributed the most to the predictions. To conclude, I have completed the full random forest workflow in this notebook. I have started from understanding the problem and the dataset. Then I have moved through pre-processing, model training, evaluation tuning, and the result interpretations. Through this notebook, I have shown how the random forest supervising learning algorithm random forest has been applied to solve the bank subscription prediction problem. Thank you.
I am going to explain how I implemented the logistic regression model for our group project. We are using the bank marketing dataset to predict whether customer will subscribe to a term deposit. I chose logistic regression because it is a powerful classification algorithm that is easy to interpret and give us clear insight into our data. First, I loaded the dataset using the Pandas library. Since the data was separated by semicolons, I used parameters to understand our target variable. I visualized its distribution. As you can see in the bar chart, there is clearly class imbalance, meaning we have significantly more no responses than yes responses. Keeping this in mind is very important for our model evaluation later. Now let's look at the most critical part, pre-processing. To make my code professional and reproducible, I created pipeline. For numerical features like age and balance, I applied the stand scaler to bring all values to same scale. For categorical features, I used one hot encoder to convert text into numbers. I combine these using column transfer. This is ensure that our data is perfectly clean before it enter the model. Then I split data into 80% training set and the 20% testing set. After training the logistic regression model, it achieved an accuracy score of 89.8%. But accuracy is not everything. To see whether the model made mistake, I generated this confusion matrix heat map. It shows that while the model is excellent and at identifying people who won't subscribe, it struggles slightly with the yes class due to the data imbalance we saw earlier. I also plotted the ROC curve and our model has AUC score of 0.90, which is mean it has very high ability to distinguish between two classes. One of the best features of logistic regression is we can see coefficients. I visualize the top 10 factors that influence customer decision. For example, the duration of the sale and the month of March appear to be strong positive indicators. This information is incredibly valuable for bank marketing team to target the right customers.
Good morning. In this project, I implemented a decision tree model to solve a machine learning problem using a real-world dataset. First, I loaded the dataset using Pandas library and explored it to understand its structure, including features, data types, and the target variable. This helps me gain a clear understanding before applying any techniques. Then I performed data pre-processing. I checked for missing values and handled them appropriately. Then I separated the data into input features and the target variable. After that, I split the dataset into training and testing test using the train test split function. This is important because it allows the model to learn from one part of the data and be tested on unseen data for fair eviction. I then select the decision tree algorithm because it's simple and easy to interpret. It works by splitting data into smaller subsets worked based on feature values, forming a tree-like structure. These splits are made using criteria like Gini index or entropy. Next, I implemented the model using a decision tree classifier from sklearn. I trained the model using the training dataset, allowing it to learn patterns and the relationship. Once I use the model to make prediction on the test data, I evaluate the performance using accuracy, confusion matrix, and classification report, which includes precision, recall, and F1 score. I also use charts to visualize the results, such as confusion matrix, performance comparisons. These visualizations made it easier to understand the model's performance and identify prediction errors. The model achieved a good level accuracy. However, I observed the decision tree can suffer from overfitting. To improve this, I suggested techniques like pruning, hyperparameters tuning, and using assembled methods like random forest. My main contribution was handling pre-processing, implementing the model, evaluating performance, and visualizing the results. Overall, the decision tree provided a simple, interpretable, and effective solution. Thank you.